Today we're going to practice graphing linear equations using a table of values. We'll start off with our rule or a function, y is equal to 2x, 2 times x that is. I'll give you the domain, which are my x values, and remember that's our independent variable, so we can select any values for x. We'll substitute them in one at a time, and we'll see the first one will give me a -4. I'll take that 2 times -1, that will give me a -2. 2 times 0 is 0, and 2 times 1 is 2. This has created or generated some ordered pairs for us to graph. So one method to graph a linear equation is by setting up a table of values and following the rule and then collecting these points and graphing them. -2, -1, 2, 3, 4. I have -1 and 2. I have something at the origin, and I have 1 and 2. And then we'll just connect our points, put arrows at both ends, and we have our graph. Let's see another problem. Again, I'll give you a domain, and it's usually in the range of anything from -3 to 3. It could be any value as I mentioned. This one, the rule says multiply it by -2 and then add 1. So -2 times -2 is 4, and 4 plus 1 is 5. I can have -2 times -1, which is 2, and 2 plus 1 is 3. -2 times 0 plus 1 is 1, and -2 times 1 is -2. -2 plus 1 is -1. Here again we have created some ordered pairs, and let's graph them. Because we're dealing with linear equations, it'll form a line on the coordinate plane. As I'm graphing these, I'm also going to take note to the direction of the line, which is the slope. I'm starting with -2 and up 1, 2, 3, 4, 5. I have -1 and 1, 2, 3, 0, 1, and 1, -1. And there is the graph of our next equation. This one's going downhill, which is negative, and this is my slope, which tells me it's a negative number. I have other examples here for us to practice, but we'll come back to them and do some of those in class. On to talking about the first form that we discussed on linear equations, which is our standard form, where we can take something like 5x plus 2y equals -6. And we could ask the question, what are the values of a, b, and c? Well, a and b are the coefficients of the x and y terms, and c is my constant. Now there'll be times when that equation will be in a different form. If it's in the form of slope-intercept form, perhaps, like you'll see here, we have to rewrite this by putting our x term to the other side. We want to get this in standard form. I'm going to subtract it over, and I'm going to get -2x plus 3y equals 6. By just one inverse operation, I can then identify that the coefficient in front of the x term is -2. In front of the b, you'll see the number 3, and our constant is 6. Let's see one more. If I gave you something in this form, and I asked for you to rewrite it in standard form, which means that x term is coming onto the other side, one inverse operation will add 4x to both sides. So I get 4x plus y equals -5. It's now in the ax plus by equals c form, so we can easily identify the x coefficient as 4. Looking in front of that b coefficient, we have 1, and my constant is -5. Now, spending a little time on standard form because we're now going to use this as a method of quick graph. Quick graphs are ways for us to graph a line without that whole series of points. We only need 2 points to graph a line. So if I'm giving you the x and y intercepts, we can graph our line. Remember, we have this coordinate plane with 4 quadrants. And if I were to find a point that didn't fall in the first, second, third, or fourth quadrant, but it fell on the x-axis, that's my x-intercept. If it's a point that falls on my y-axis, it's my y-intercept. So this is telling me that the x-intercept is 5, 1, 2, 3, 4, 5. I have it graphed right there. And my y-intercept is -2, down 2. And if I connect those points, I have a graph. Let's see that again. Here are my intercepts. My x-intercept is -4, and my y-intercept is -6. How do I go about graphing them? Well, I know a point on the x-axis is going to be -4, 0. So I'm going to go on my x-axis over to -1, -2, -3, -4. There's my first point. A point on the y-axis has an x value of 0. So I'll go 0, 1, 2, 3, 4, 5, 6. Let's move that up a little so we can see it. I have 2 points. I have a graph. Quick graph method. If you're given the intercepts, it's just that easy. However, there'll be times when you have to find your intercepts. So what does that mean if you need to find them? We're going to take them one at a time and set the opposite variable to 0. So now if I want to solve for my x-intercept, I'm going to put y as 0. And you're going to see that simplifies to 2x is equal to 4. So x is equal to 2. Go to my graph, and there's my x-intercept. I now have to find a y-intercept because remember we need 2 points. Staying with that original equation, 2x plus y equals 4. If x were now equal to 0, it would cancel out. If it cancels out, I am left with y is equal to 4. So I'll go to my coordinate plane, and I will count up on the y-axis 1, 2, 3, 4, connect my points, and I have a line. By setting one or the other to 0, we'll find the intercept. Let's see a second problem. To find my x-intercept, I'll set y equal to 0. What does that look like? -3x plus 2 times 0 equals 6. I'm replacing x with 0. Do I have to write this step? No, because we know anything times 0 is 0. So I then can go right to -3x is equal to 6. Do one inverse operation. And I get x is equal to -2. My x-intercept, point on the x-axis, is -2. Let's find the y-intercept. That means this time x is going to be equal to 0. Do I have to write this step? No, because it cancels out and I'm left with 2y is equal to 6. We'll divide both sides by 2 and my y-intercept is 3. When x was equal to 0, y was equal to 3. In the first, when x was equal to -2, y was 0. So 0, 3, 1, 2, 3 is right there on the y-axis. Connect, and there's your graph. We'll do more of these for practice in class.